and welcome to everyone to this workshop. This is the first time we have this specific workshop at ECSS, and we do hope that this will be a good start for future development. Especially, we do hope that this kind of workshop will be useful for all the audience, for all of you young researchers, of course. And thanks also to my older colleagues to be here and to share with you this workshop experience. The purpose is exactly to put together different generations, essentially, and to help creating a network that includes everyone. So, unfortunately, my colleague, Standa, the other workshop co-chair, could not attend for two reasons. First of all, he comes from UK, and he was essentially his university did not allow him to travel, unfortunately. So he was planning to attend online, but then he got sick, and today he is very sick and could not even open the computer. So he is not here today for this workshop, but of course he apologizes, but we will try to handle without him. And I have other people here who are going to help me on the go. So the goal, I don't have the possibility to move the slides now. Maybe you need to put in foreground okay. So the goal of the workshop has been already stated. So we would like to support you in the development of your soft skills, presentation abilities, networking, how to develop a research plan, etc. Of course, we are not going to do everything today, but this is a start, and then we do hope that this thread is going to develop. For the workshop, the format has been that we launched a call for paper. We have got a number of submissions, 18 if I'm not mistaken, and then we have been evaluated them. We have considered all of them good for presentation, and so we are going to have a poster session where you are going to present your work, and post-proceedings. So we will create, starting from the end of this workshop, we will start creating these proceedings and start asking you to get your submissions for these post-proceedings. And then we have keynote speeches, and then panels and networking sessions. Networking sessions will be completely informal in the sense that during breaks, lunch, dinner, we encourage you to join the others and to make sure that you talk to people and you try to learn as much as possible from the experience of the others, because in the end, this is probably the best way to learn. The program, once again, I cannot move the slides, Kitman. And the program is here, okay? And okay, this is the welcome. Of course, we are late, and then we are starting this session with keynotes, and we are having our first keynote from remote, Justyna Petke. She is from University College London, and she will focus on how to achieve high-quality research. And then we have Gerardine Fitzpatrick here, and then Lynda Hardman. And then we are going to have from remote Wolfgang Emmerich. So Gerardine will be focusing on how to create a good environment for clever people, and Lynda will share her experience on career development, how she developed her career, and of course give suggestions on this. Wolfgang is both a university professor and he is also working for industry, so he will share with us this experience of moving from university to industry, and also bringing into industry research results that are developed within a university. Then we are going to have the lunch break, and in the afternoon we are going to have two panels. I cannot move the slides, but the two panels are: the first one shared with our older colleagues in in the leadership workshop. And so the focus will be on open science. And we will try to reflect on this theme that has an impact, both positive and negative, on career development. So we need to really learn about it. And then we are going to have another panel discussion with industrial people. So people working in industry who are going to tell us their viewpoint on career development and PhD and industry. And then we are going to have this welcome cocktail, and within the context of the cocktail, we are going to have your poster sessions. Did you bring your posters? Okay, great. So they will be displayed in the same area where we are going to have this cocktail. And so the idea is that that will be an opportunity for you to present your work, your scientific work, to the audience. Okay, and also to get to know other people, which is the important aspect here of this conference. Let me just to remark the fact that ECSS is a conference that is not specific, that is not focusing on a specific research field in information technology, is a conference that is aiming at creating a community. And so we are emphasizing here more the networking aspects exactly because of the purpose of ECSS and the kind of service that ECSS wants to offer to the community. There was a last slide, I think, but just to have, I cannot move, but to remark the fact that ECSS is part of Informatics Europe. And Informatics Europe is an association that we invite you to know, and we invite you to learn about the services that it offers, because it is quite useful for all of us. So I'll give the floor to Justyna, and in particular, yes, Kit Van now is going to manage the thing. And just to avoid any problem, we wanted to be highly fault tolerant. We have a video of Justyna's presentation, and that is going to start now.
My name is Justyna Petke, also pronounced Justyna Petke, and today I'm going to talk to you about how to achieve high-quality research. Firstly, let me apologize for not being able to attend live. However, I plan to join later for the discussion session, so if you have any questions, please ask me them. I'll start with a few words about me and about my research experience. First, I did a doctorate in computer science at the University of Oxford. My thesis was full of proofs. Next, I moved on to software engineering, in particular software testing, and did some research in that at University College London, where I also got interested in automated software improvement, and currently continue to pursue work in this direction. My work requires large-scale experiments on real-world software, and I have a grant to help me develop the techniques. Moreover, I'm teaching an MSc module on research methods in software engineering, and some of the things I'm going to talk to you about come from that course. Before we dive into how to achieve high-quality research, let me first ask you, what are the features of good, high-quality research? At many conferences, we, as reviewers, are asked to evaluate submissions against the following 5 criteria: novelty, soundness, significance, presentation, and reproducibility, verifiability, etc. Therefore, I will focus on each of these items in order. Let's start with novelty. How to ensure what we do is novel? Back in 2010, I was giving my very first talk at the main track of a conference. That was the International Conference on Principles and Practice of Constraint Programming. I even received a Best Paper nomination for the work. I came to St. Andrews, I gave my talk, and then one of the first questions I was asked from the audience was whether this work hasn't been already done back in the 70s. Fortunately, someone else in the audience knew the work that was referred to and clarified that although the theorem was stated in that paper, it was never actually proven. Of course, until me and my supervisor presented the proof at that conference. The paper from the 70s hasn't come up in my literature review, and I'd imagine partly because, at least at the time, only a picture of the manuscript was available online, and the full text was not searchable. Here's another, more recent instance of the importance of literature review. This comes from the field of machine learning, and there was a lot of discussion about it on various fora just 3-4 weeks ago, so I thought it might be interesting to mention it here. What happened was that paper B was accepted to a conference, and it was published on Archive, I believe in September this year. Shortly after, authors of another paper accused authors of paper B of plagiarism. Let's call it paper A. And paper A was published on Archive just a few months prior and was at the time under review for another venue. Authors of that paper even posted a long post on how papers A and B are similar. What happened next was that on a Reddit thread about this, someone else noted that actually paper B has already been plagiarizing paper C. That was rejected from a conference a year prior. What's happened there is that authors of paper C actually haven't released that paper publicly, but it has gone through a reviewing process and was later copied, almost word for word, by authors of paper B. In the end, authors of papers A and C both provided evidence that indeed they've come up with the ideas independently and also emphasized the differences between the two works. This just shows that even if you do a proper literature review, you might still miss some research, and people can think of the same ideas independently and publish within the same time. So there is no golden rule really to avoid such situations. However, you can do your best effort to avoid that, and I would like to recommend this paper. It presents guidelines on how to perform systematic literature reviews in software engineering. But these guidelines, I would say, apply to any literature review, so I think you might find it useful. Another quality of good, high-quality research is soundness. You want your work to be sound. What does that mean? There are lots of research methods. In computer science, most commonly, there are proofs, experiments, it can also be case studies, surveys, and other. So make sure to always ask yourself a question: if an appropriate research method has been used for the problem at hand and hasn't been used correctly. One practice would be to develop some new technique and then try to find the problem to which you can apply it. You should really be motivated by the problem and then try to find the best method to tackle the problem. Here, the community-driven effort for providing empirical standards in software engineering could be of help. Again, it's probably, it's directed at software engineers. However, there are some general rules, good advice on how to conduct literature review as well, but also some good features of experiments, case studies, and other. So what could happen if something has not been done correctly? What happens if unsound techniques are used? You might have heard of some spreadsheet bugs in the media from time to time. I'm going to go over one particular one. So back in 2010, Reinhardt and Rogoff showed that the average economic growth of a country slows when its debt rises to more than 90% of this country's GDP. This paper was used as an argument by various government officials to vote for and introduce austerity measures. And in particular, one of the affected countries was Greece after the economic crisis of 2008. It turns out a few years later that there was a mistake in the formulas in the spreadsheet. Thomas Hendron and others have got the data from the original 2010 paper and identified a few errors. One of the more severe ones, I would say, was that data for 5 countries has not been taken into account, because the spreadsheet formula simply failed to miss one row that contained that data. So when the Thomas Hendron and others reanalyzed the data using correct formulas, they showed that actually average economic growth increases rather than slows down when the country's debt rises to more than 90% GDP, basically invalidating previous results. And obviously this work had a huge impact in government policies. So that's why you should definitely make sure that your work is sound. It is worth noting, however, that Reinhard and Rogov made their data available so that other researchers could verify their findings, which is what took place in this case. The next quality of good research is significance. Here, you'd like to think about beneficiaries. So, who can benefit from the work that you do? These can be academic beneficiaries, so maybe people directly in your field, in the perhaps even narrow discipline you're working on, but also perhaps your contribution can have a wider impact, not only in the general field you're working in, but also in other fields of research. And other types of beneficiaries could be the software industry, software developers, but also end users of the software to which your technique has been applied to. Let me give you an example from our research group. We had a paper come out from our group on automated test input generation for Android a few years back. And then people involved with this work joined Facebook. And now if you have a phone with Facebook software running on an Android device, then it has fewer bugs thanks to the technique that was discovered in our group. So impact has followed from academia to industry to the end users. So impact is something that's very important for grant applications, which maybe postdocs among you might have already have some experience with. The impact of research that you propose to be funded is crucial. A few tips here. When you're doing research, think of the larger problem you're trying to tackle. What are the potential broader consequences of your work? What happens if you scale up the given technique? How does it benefit people who apply your technique, who may be doing research in the same area? Think about not only immediate beneficiaries, immediate consequences of your work, but also future potential ones, even in the years to come. So always try to think about who your research benefits, and that will help you point out the significance and potential impact of your work. Another good tip is to think about how you phrase your research. So for instance, what happens if the result you're trying to prove turns out not to be not true? Is this still an interesting contribution to knowledge? In our work, for instance, instead of asking a question of whether you can automatically transplant a piece of code from one software to another to add a new feature in an automated way, we ask to what extent this is possible, with the techniques and the time and the techniques we were developing. So that kind of showed the state of the art and pointed out what still needs achieving. Just thinking about what would happen if you get a negative result is important for like experimental work that takes months to complete. So you might set up an experiment with one idea in mind, and then it might take months to complete, and then it turns out that your hypothesis is not true. So think about how you can phrase your research, I guess, in a way, your hypothesis in a way that whichever where results go, that would it be interesting and important. Another feature of high quality research is its presentation. And here I'm also talking about communication of your research. I want to emphasize here, do not underestimate the importance of writing up. Perhaps, who knows, maybe in the aforementioned machine learning case, if paper C was better presented, maybe its significance would have been more better shown, better recognized, and the paper would have been accepted rather than rejected, and the follow-up work, plagiarizing work, would not have come to be. Secondly, make sure to talk about your work to your colleagues, people at conferences, workshops. Basically, talk to everyone about your research so that you can get some feedback and maybe perhaps new ideas can emerge. One relatively recent example would be when I had a visiting professor, an expert in software testing visit. That was just before the pandemic hit. My area of expertise is in automated software improvement, and in our group we also have an expert in information theory. Theoretically, three different areas of software engineering and computer science. And we were all together in one room for a few days, and when we came up with an idea that led to a recent publication, and hopefully many more to come. It's on reducing information leakage in software using automated program repair. So I would just encourage you to talk to your peers and also people at conferences. Finally, I would encourage you to submit to top venues, because if you do submit to those venues, your work will likely be reviewed by the best experts in the field. Thus, hopefully, you'll get very good feedback and will know how to make your research even better. It is somewhat more risky in terms of getting a publication, because those venues are hard to get to. That's why you know they're top quality, because they try to accept the best work. So the feedback you get might be invaluable and could help you revise your work, so that eventually when you do publish it, it will just be much better than it would have been otherwise. The last feature of good research and high quality research I want to talk to you about is reproducibility, replicability, also referred to, depending on the venue, verifiability and transparency. So if you work with proof theorems, then be sure that they're self-contained. I know there are like paper page limits, but even so, usually an appendix is allowed. So make sure to add enough information so that someone else could then verify your proof and that everything's clear how you came up with the proof itself. You'll help the reviewers figure out whether the proofs follow, and it will be more transparent what you've done. If you produce a piece of software, then the obvious thing to do would be to open source it. And there are various websites that can facilitate this task so that the code can be submitted with a research paper and then later released. So there are services such as Zenodo or Figshare. There's also GitHub, GitLab. Nowadays there are lots of repositories through which you can share the code. There is also a workshop on open science today, so I won't go here into much detail. Nowadays, there are also more and more artifact evaluation tracks where your research is verified by a committee that specifically checks whether the code you submitted can be run, how usable it is, and basically whether the experiments can be replicated. I should say that these have only started appearing at conferences in the last 2-3 years. Unfortunately, up until recently, and even now providing open source code and scripts has not been a requirement for acceptance of research work. But there has been a big push towards that in recent years, which is appreciated. Conferences like Popul, XC have such tracks, which and obviously authors are encouraged to open source their work and make code available. This brings me to the next point, which is maintainability. Unfortunately, there isn't yet still much incentive in the academic community, I believe, to maintain software, which hasn't been a bit of a problem in my recent research, where we're looking into Profiler for Android software. It turns out that we only found one really that was usable. A lot of the links to the code, well, no longer pointed to the code, websites didn't exist, or were pointing to software that could only run with very old versions of Android. Unfortunately, as I said, there isn't much incentive in the race for publication to maintain the artifacts. However, I do want to say that if you do maintain a piece of software and people do use it, then they will obviously cite your work, say that they've used it, they can build upon it. They won't have to, shall we say, write something from scratch just to be able to extend your work, to build upon your work. So they encourage you to really maintain artifacts you produce simply because they might later on have a more wide-reaching impact. And who knows, might lead to even more collaborations. To sum up, I talked about 5 features of high-quality research. As far as novelty is concerned, a thorough literature review is key. In terms of soundness, applying the right techniques to your problem in the correct way is important. And this, I didn't mention that, but this also includes the right statistical test, so you can derive at the right conclusions. When you think about the significance of the work that you do, think about the beneficiaries. So who can benefit from your work? Not only like your immediate maybe research community, but also think about what sort of consequences your work could have in the future. In terms of presentation, take every opportunity to talk about your work, including at this event actually, and get feedback, and that will help you improve your work. And do submit to top venues. Finally, practice open science. Make sure that your work that you produce is indeed verifiable, reproducible, and replicable. Then more people are going to be able to build upon your work. And I'll leave you with this XKCD comic on what could happen if you don't follow good practice. So I hope you found this talk useful, and thank you very much for listening.
Now we have Gerardine, who is already writing something in the whiteboard, and she will give her presentation shortly.
So, is everybody in? Okay. This is just just to get a sense of where you're all at. So, PhD, postdoc, tenure track, faculty, like in a sort of permanent position, or whatever other category you may want to be. So mostly PhDs and postdocs. If anyone feels free, how postdoc are you? Is it new? Move on. How far into the postdoc? First years? First year, so fairly new into the postdoc phase. Great. Curious, do you think of yourself as a leader in research, whatever you might think that is? Yeah, yep. So lots of no's sometimes and not sure, so it's not clear what that actually means. Do you aspire to be a leader in research, whatever you think that might mean? So the main message that I'd love you to go away with from whatever I end up talking about today is you are already a leader in your everyday interactions. You're a leader in the topic ideas, in the content that you're researching, and that's often what we tend to think about, and it's often what we're trained to do well. And we are also leaders in enabling all of us to do good research together. And I hope that I can unpack that a little bit in the course. So I'm just curious, has anyone had any leadership training in the course of your... Oh, so that's encouraging to even see 5. That's 6, 7. That's great. Great. So it is something that is happening. Overall, what are your own experiences of research leadership directly? Again, whatever that means, however you want to interpret it. Have you experienced good leadership research? Bad? So this sort of, the number is the average and the bumps is where, so there are quite a few, some people have said no here or, terrible. There maybe, I don't know how many, what numbers this is, great. But in the middle, so room for improvement, that would suggest, in whatever way we might think that is. This is a word cloud. So you can just put in any word that you want, and the more people who put in the same word, that word grows bigger, not that you have to do that. But what have been some of the specific qualities or issues or experiences that you've had that you would frame as bad leadership or towards the bad leadership in some way? No leadership at all, so left floundering from someone. Not listening, giving orders, telling you what to do. The hierarchies, the negativity, no feedback. The hierarchies, the micromanaging, yeah. So the orders and the micromanaging, the shouting. Oh, that breaks my heart to think that people are in environments where you get shouted at. But these aren't uncommon experiences. And we don't do research in a bubble. We do our research within a social context, and the other people we work with matter. And think about how you felt as well in these situations where these sorts of behaviours have happened. So again, what else has come up here? Not asking questions, not listening. The no feedback are two big things. So not getting any sort of support or guidance. Poor delegation, no planning. So there are some skills there that can be further developed. Now, I assume that a lot of what we might see here, it might be the opposite of some of those, but you know, what in particular have made for really good experiences for you? Listening, encouraging, inspiring, communication, trust, praise, feedback and acknowledgement, fast communication, clarity in communication in the clear feedback, leading by example, role modelling, take the difficult decisions, motivating feedback. That's brilliant. And again, just think about how you actually feel in the middle of one of those sorts of interactions. You know, you sit up taller, you stand up taller, you feel better. And the research says, there's a theory by Barbara Fredrickson that talks about broaden and build, that when we're in these sorts of situations that create more constructive, positive, supportive environments, we actually broaden our mental horizons. We come up with more creative ideas. We're more productive. We're happier. There are physical and mental well-being impacts. There's a lot of sound psychological evidence repeated across numerous studies that would pass Justyne's quality criteria that talk about how this stuff is good for science. Because what the research also shows is when we're subject to some of those bad leadership qualities, we close in, we get fearful, there's a sense of vulnerability, there's shame, there's, you know, we're afraid to admit mistakes, we're not seen, we're not acknowledged, we're not encouraged, and we're floundering. And that's not good for science. And you think about computer science these days and what was said at the introduction by Enrico about the really critical problems that computer science and informatics are implicated in. And that means you and I are implicated in these, solving these really serious problems for society. So we want to bring our best brains, our best people, our best environments to solving this. So we want situations that are more like this. And I can't remember if I've got any more here. Is that the last one? That's the last one. So we can stop sharing this. Kit 1, could you stop sharing the presentation, please? Saying I can't. So I have no slides, so that's the end of any sort of presentation. And I've already gone off from what I was going to say anyway. But what I want to put to you is you are already leaders. Because you can do a lot of those, what were the positive aspects of leadership around listening and support and encouraging for each other as well as for anyone who you may be line managing in any particular way. So you can be enacting good leadership behaviours right now that help contribute to creating constructive, collaborative, collegial research environments where we have our broaden and build mindsets, where we're going to do our best science, do our best problem solving, be our most creative. Now, there's a definition from Brené Brown, who's a scientist, but sort of a popular scientist we can discuss. And she talks about a leader being anyone who can find the potential in people and processes, and who has the courage to develop that potential. And I think that's a really interesting definition of leadership, because it puts all the focus on the social context and the people that we're working with. And I can just tell you from my own experience of not enacting good leadership behaviours and doing many of the things that are on your bad slide, because many of us don't have any training in this, and it's not something we think about. And also the very culture of academia sets up, with our performance metrics and career expectations that we ought to do all of these steps and we ought to be like the rock star researchers. I hate that language. There are these expectations that we ought to be something else. And so I remember in my very first postdoc job, I was working in a research centre, and I had a research assistant who was working with me, and we had access to this amazing data set. It was actually the precursor of things like Slack now. And I had no idea how to analyse this data set. And she was a new research assistant, and she didn't really have any experience. So she would look to me for telling what to do, but I didn't really know what to do. So we just sort of floundered around. And we ended up having this really high-profile researcher, international researcher, coming and visiting our research institute in Australia, who was in the HCI area, which is my research area. And if I only had have said to her, could you help us analyse this data set? I'm lost in what to do. But I did not have the courage to do that, because I didn't want to be found out as not knowing what I ought to be doing, and I certainly didn't want to show it to someone who was, who was sort of very senior. And then I thought, maybe, and they might steal the data. I mean, how silly. I missed this amazing opportunity to develop my own potential and the potential of Donna, the research assistant, and to produce good science that I think could have informed lots of other things, because we never ended up publishing anything from that, because I was paralysed by my own insecurities. And I come from a background where neither of my parents went to high school, let alone university. So, the imposter and I are very good friends, where, who am I to be here? And I'm going to get found out soon, and I'm really not very good, and to cover that up also is the bit of perfectionism, because because you can't be found out, you've got to do everything perfectly, and you put all these expectations on yourself. So my next story is later on, after I'd been in the research centre, I'd worked in industry for a while, I went into my first academic job in a university. And somehow I blagged my way into a senior lecturer position, so my first day stepping into a university context. And I had inherited a big bunch of research projects and funding and people, and I was totally out of my depth again. And I wore the burden very heavily, because before with Donna, as a postdoc, I was what I would call a little L leader. Like no one called me a leader. I was just the postdoc, and Donna was working with me. Whereas in this position, I was the big L leader. I was in charge of the group, and it scared me. And I felt like it was all up to me to make it work, and I had to do everything perfectly. And I remember one particular instance where I had a couple of really good postdocs who'd been working on a project for a number of months, setting up a field trial. And the field trial was coming, the day of the field trial, they were literally out in the field setting up the equipment, and I came in to help them. And so I came into the room where all the planning and prep was going on, you know, for the other parts, and I saw the interview forms that they had. And I thought, oh, what are they asking these questions for? This could be framed much better this way. And so I sat there and very quickly reordered some of the interview questions and changed some of the wording, and we had a number of people who were doing the interviews, so I handed out the revised interview forms for everyone who's doing the interviews. And when the two postdocs came back in from the field, having set up the equipment, they were really annoyed at me. And you can imagine why. Because I had done so many of those things that were on the bad slide. I'd undermined them in an incredible way. I didn't talk to them. I didn't even tell them I was doing it, let alone ask them, let alone actually stop to think, did I even need to do it? And I didn't need to do it. The questions that they had would have been more than good enough. We would have got more than good enough data from the participants, and instead I violated some of the really basic principles about what makes people tick. And that's, autonomy, the things that you've said here, the autonomy, the competence, the being trusted, the communication. And if I really had have had a really strong belief that it could have impacted the research, I could have approached it in an entirely different way. That came to them as a colleague, that engaged them in a discussion, that just put a point of view on the table without any hold on whether we did anything with it, and engaged in a dialogue together. Maybe we could have ended up in somewhere so much better, and with our relationships still intact, because that killed our relationships there, and they still haven't really recovered well. And I don't blame them. So I have many other stories that I can tell you that haven't been done out of malice, but just out of lack of insight or knowledge or reflection. And I've also been at the receiving end of bad leadership as well, and I know what it feels like in terms of being undermined myself, or having contributions in meetings actually physically ignored, with the head of department sort of turning their body away whenever I would say anything, or having ideas in research projects and people scoff and laugh at them. And these, I'm not going to speak up again in those contexts. We can make a difference to people. And I think the key insights for me in reflecting on all of these, so, I won't go into the epiphany sort of moment or time, where things transitioned a bit, but let's just say, the burden of carrying that responsibility in that first lectureship job, with some other contextual things that happened that weren't so good, I ended up at pretty much a breaking point. And I think some of the key insights that came out of my journey out of that have been about leadership is not about me. Like, it's not my reputation and my profile and I've got to make this group work and it's all down to me. It's about we. We're in it together and we have different roles. Research always takes place within a social context. Always. Even if you think you're sitting there working on your own topic that no one else in your group is working on, you are still in a social context with your peers, in the professional community, with the people who might share an office with you. And we can be there for each other and enact leadership-like behaviours right now, even if we don't carry a big L label. And the other thing that I learned was that it's okay not to know. Because I think one of the things that I felt pressured about was that I'm the big L leader, I ought to have all the answers, or I'm the postdoc, I ought to have all the answers. And I don't ought to have all the answers. No one has all the answers. And we're going to come up with better answers together. And so the learning, that lesson is about these are a set of skills that I can learn, and that it's okay to say I don't know if it's something content or process related, and it's okay to say I'm sorry I was wrong. These are really important things, and it's a journey. So I want to propose that if we take, my old lady glasses, if we take leadership, if we think about leadership in some different ways, and if we go back to that definition of leadership about being, finding the potential in people and processes and having the courage to develop that potential, I want to propose two directions that we can do that from. And the first direction is we need to lead ourselves. Because what about developing our own potential? We don't have to aspire to the shoulds and ought tos and, we're only good if we have an H index of blah. What is your potential as your unique person, as your unique researcher self? What are the particular things that you care about that are important to you? What are the particular strengths that you bring to your work that make your work great, the work that you love doing? What difference do you want to make in the world? Now that may end up looking like, a career path that can be fairly standard, and it may end up resulting in an H index that's, whatever level. But if you only go chasing the external shoulds from the external pressures without thinking about developing my own capabilities and potential and who I am, I can guarantee you, you will never be happy as a researcher or in any profession. And there are some lovely, I host a podcast series called Changing Academic Life. And there are some lovely stories there from people who show that you can make principled decisions around your own potential, your own values, what's important, and be happy. And it may be different. So Evan Peck, for example, was encouraged to go to one of the research-intensive universities for his postdoc. And he decided he really cared about family and he loved teaching, and he knew that if he did research intensive, people were telling him, don't worry about teaching, just get it done. And it didn't feel right. And he went to a community college, which by the standard career progression wouldn't have been the good thing. And he's really happy and he's doing great work. So what's your potential? How do you lead yourself? And the other part of leading yourself is making sure you bring your best self to your work, and that's all of the work-life balance stuff. I hate that term, but it captures the sense of looking after yourself, because if you're not well physically, mentally, and so on, you're not going to be doing your best work. And you owe it to science to bring your best self to work. And there's some really nice research from Berkeley University that talks about well-being being a critical enabler for good science. Not a nice to have, not a if I have time. We've got to prioritise it. So lead yourself is the first way that I think leadership plays out in research. And the second way is leading others. Now, I'm not going to talk about the big L leadership because that's, there are a whole lot of other issues involved in that. I want to talk about the leading others in our everyday interactions. And you can be surprised at how much power we have to influence. So someone said, you know, some of the items that came up there in the sort of bad and the good, you know, was about listening and communication. We can do that for our colleagues. When we come into the office in the morning, rather than just going, yeah, how you going, and walk past, we can actually stop and say, how are you going today? Yeah, I mean, you're not going to do that because that's a bit freaky, but you know, you can actually stop and just give a little bit of attention and say, how are you going? Or if you know that someone's having a hard time solving a problem, listen. Just be available to one another. It doesn't take much time. There was an issue there about praise. When was the last time someone praised you for something that you did? When was the last time you praised someone else for something that they did? We can do that for each other. And it feels good because we all want to be seen and heard and acknowledged in our work context. So we can do that for each other. We can say, thank you for the way you led on writing that last paper that we collaborated on. I really appreciated your structured thinking that got us there to the end. What did that take? 5 seconds, 10 seconds? Genuine, specific, and generous in saying thanks. So not just saying thanks, but really be specific. Say what it is that you liked about them, because that also helps them get to work out what they're good at, what their potential is. So, you know, the colleague that I co-facilitate a leadership development course for Informatics Europe, and my co-organiser, he's wonderfully structured in a way that I'm not in his thinking, which is really great. And, you know, like maybe some people aren't aware that they bring particular strengths and skills to something because it's just something they do. And you don't think that everyone should be able to do it because it just comes so naturally to you, but it doesn't. And to have other people reflect back to you and say, thank you for being so structured in your thinking, or thank you for taking the time to do this in this particular way that you did. These things can matter. This is enacting leadership behaviours in our everyday interactions. And there's small actions that can have huge impacts. And they go to creating collegial, collaborative environments that enable that broaden and build mindset for enabling good science. And the final point I just want to raise in the sort of daily interactions with one another is that picking up on the listening again, and it's how we listen. And, you know, and how we take off our advice monster hat and really just recognise that we're working with clever people. So if someone comes to you and says, oh, I'm really struggling to do this, blah, blah, you think of what your first response is. It's often, oh, you should, or have you tried? You know, we immediately go into problem-solving mode. And think about yourself when people have done that to you. I don't know about you, but I often sort of feel like, yeah, I've thought about all that, duh, you know, like, but when we're dealing with clever people, any people, all people are clever in their own ways, actually just taking the time to help them think through. You know, would it be helpful if we do you want to just think through it now? You know, what have you been thinking about so far? You know, which of these do you think would work best, or which, you know, if you had to pick one now, what one might you try, do you think? Is there anyone else who could help you? You know, and you can still offer a suggestion, but you're not doing it from the should mode. You can sort of say, I could also offer some input, and it's sort of, you're just putting an offering on the table that people can take up or not. And it's a very different mindset and interaction. And I fell into the trap of that. I'm pointing to my computer because it was on a Slack chat with one of my great fellow lecturers in our group who at the weekend was saying something that she was having problems with. And I immediately went into advice mode. And I had to stop in the middle of the interaction and say, oh, I'm going into advice mode, because she was telling me something that she'd already thought about heaps, and I wasn't telling her anything new in my advice mode. So I just said to her, what do you need from me now? What can I do to support you? I said apologies for the advice mode first. But these are the things that can make a difference, that can enable us to have good science, good environments, good science, and enable clever people to be clever and to develop our own potential, the potential of others, and do it collectively. So that's, I have no idea what the time is or how we're going. Sorry? So I'll finish there and just say that you are the future of the Academy. You're the future of informatics. You're going to be sitting up on that stage in some years to come, welcoming everyone to ECSS. And you can be part of changing the culture in the Academy towards more of what you said in that good leadership slide. And you can do that right now. You don't have to wait for a bigger label. You can do that right now in your everyday interactions with people and creating great work environments for good research to happen. Thank you.
Good morning, everybody. I'm Lynda Hardman. I live in Amsterdam with my husband. I've got 2 kids. My son is 25, my daughter is 22. I'm a generally very happy person. I'm difficult to insult, so you can keep that in mind during lunch. You can try, but I'm hard. I work full-time. I cycle everywhere in Amsterdam. I try to fit in fitness and yoga and running, so exactly the advice that Gerardine is giving us. My husband also works in academia. We both love our work, and we've devoted a lot of time in the past to both our kids. And actually, to be honest, even now, we still devote time to our kids, but in a different way, in a great way. So this is me. As you see, I stuck around in academia, I stuck around in computer science for 30, 40 years. I've worked for nearly 30 years at CWI. That's the Dutch Research Centre for Mathematics and Computer Science. And I'm currently a full professor at Utrecht University, 1 day a week, in multimedia discourse interaction. In my research life, I've been working many years on designing user interfaces for providing access to large quantities of information. And I'm currently working on, are you ready for it? Topic-based literature exploration using augmented reality. So I'd love to talk about that during the lunch, but that's not what this talk's about. What this talk is about is me reflecting on the transitions I've had in my career. And these are many and varied, so I hope this will be of interest. And share some insights with you. Basically, like I said, I'm this sort of happy-go-lucky person. I go with the flow. And this is how I approached my career. And sometime during my career, it suddenly occurred to me that, oh, wait a minute, I'm not actually going anywhere. I'm just sort of here. Is that good? Is that bad? And I realized that in some cases, I was being pulled through my career, through people I had met. And then later on in my career, I started to push. So this is my story about how I learned to push. And, you can start pushing now if you wish, or you can continue to float along the river and be pulled into places which could be interesting to go, or you might want to go somewhere else. And next slide, please. So where did my career start? How did I get to where I am now? So I studied physics and maths at Glasgow University in Scotland. I had intended to have an academic career in physics. I was going to work in CERN and do all these neutron colliders and stuff like that. However, having studied physics at Glasgow University, I'm sorry, I didn't like physics anymore, so I had to find a job. So I started working as a computer scientist, a programmer, in a place near Edinburgh called Dalkeith Palace. This is Dalkeith Palace. It's an amazing place. It's now actually open to the public, so if you're ever in Edinburgh, I certainly recommend you go and visit the palace. And the reason that I felt that a career in programming would be quite nice was we could play snooker in the basement. Next slide, please. And because it was in these beautiful grounds, I could sunbathe while I was programming the microprocessing code for the PERC workstation at International Computers Limited. This is also where I got my first yoga lessons, of all places. So one of the programmers, mostly guys that work there, right? And one of the guys, his wife was a yoga teacher, and she would come to the ballroom in the palace and we'd get yoga lessons. What was I doing for work? I was creating printer drivers for a laser printer from Japan for the POS operating system. Okay. However, I only worked for about a year at ICL because they decided to move the whole process to somewhere else in the UK. I didn't want to go. However, my boss's boss in this organization was Ian Ritchie, and he became very influential in the rest of my career, actually. So wherever you are, where you are, you're meeting people, that's your network. And you never know who's going to be influential, but some people are. And, you know, be nice to people all the time, because they're going to come back in your life later. So anyway, I stayed in Edinburgh. Next slide, please. And then I worked for, again, a short time at Edinburgh University in the Artificial Intelligence Department. So I was there in 1983, 1984. And even then, it was occurring to me that, hey, where are all the girls? So I participate in events to help attract more schoolgirls to come do AI or computer science at the university. However, I'd purchased a house, these things happen, and the salary I was getting at university wasn't actually enough to pay my mortgage and feed me, so that was a bit tricky. And my colleagues at the ICL had set up a startup company. And one of them, Ian Ritchie, he asked if I would join the startup company again as a programmer. So this was the first time I was pulled into position. So somebody knew me, they were setting a startup. Oh, Lynda, will you come and work for us? I went, yeah, sure, why not? And there we were creating a system for, and this you will understand because you all understand machine learning now, making automatic decision trees based on input data. So this was really machine learning in the mid-'80s, I think. The company went bust within 6 weeks of me arriving there. So I was jobless for a second time in less than a year. Hey, but I'm happy, right? Next slide, please. Sorry. So I joined a second startup company, again with ex-colleagues from ICL. And we worked on a number of projects to do with creating interfaces to information. So this is really, I think, one of the themes of my career is how we interact with information. And this system called Windows, it was very new on the market from Microsoft. And in 1986, I was working on a hypertext product. Hypertext, this is very new. You have text, and then somewhere you can click on it, you jump to some other text. Ooh. And it was occurring to me in this inspirational old school environment. This was an old primary school, and the windows are high enough so the kids can't see out and get distracted. So we're all sitting there programming, not getting distracted. We worked on initial versions of Guide for Mac and Windows. So this was a hypertext system for end users. It had, actually, you'd probably recognize the interface now if you saw it. It was a bit like the web as we know it these days. However, I noticed the potential of this new technology and realized we didn't really know what we were doing. We were just creating yet another software system, but this whole hypertext stuff, there was something interesting there. So I came into contact with the Scottish HCI Centre. This was relatively new. Scotland was actually investing into HCI in the mid-'80s. So I think 1983 was the first year CHI was started, something like that. So this is the beginning of human-computer interaction as a field. And my bright idea at the time was that I would work half-time at the company doing the programming and the software, and then half-time at university, understanding how people would interact with these hypertext systems. However, my boss at the time said, oh, no, 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 you can't possibly have two bosses. And now in my job in Amsterdam, I'm the director of Amsterdam Data Science. The whole idea is we try and get academics to work part-time in industry and people in industry to come and lecture part-time in academia to, if you like, increase the flow of information across these two different cultures. So if you ever feel like doing something like that, come and chat to me and we can talk about it. So the attitude's changed in at least 30 years. Sorry, my throat's not good. However, having left the company to go to university, I later came back to the company to work on research, so researching hypertext for education. And when I was working for the company again, one of my good friends and colleague at the company came along to me one day and said, hey, I've got a pay rise. And I looked at him and said, what do you mean you've got a pay rise? Yay, they gave me a pay rise. I went, what? So I stormed off to my manager and said, look, what I do is just as good as what he does. Why don't I get a pay rise? And they went, oh yeah, yes, you probably should get a pay rise. And it was like, it hadn't occurred to me to even think to go to my boss to negotiate more money. It just wasn't in me. I just expect money to rain on me from above, I don't know. So this was a point in my career where I thought, oh, you actually have to ask for things sometimes. Because you know you do good work, but if you're not telling other people and they're not noticing, you have to remind them of your good work. Politely. So during this time, I moved to Amsterdam. My partner is Dutch. But I stayed employed by the company. So I was working for an Edinburgh company in Amsterdam. But when times got tough for the company, then their research department in Amsterdam is a luxury they can do without. And so, hey, I had to look for another job. Next slide, please. So this was CWI. I had a desk at CWI while I was working for the company in Edinburgh. And the company actually paid for office space in the institute, which was very good of them. I looked for a job somewhere else in the Netherlands. And actually, 5 months I was unemployed. And this was probably the most difficult 5 months of my life. I had a partner, he was Dutch, he was out working every day. I was in the flat looking for a job, or sitting at CWI looking for a job. I didn't know what was going to happen. My Dutch wasn't as good as it is now, so it was pretty tough not working. I didn't enjoy that. However, at some point, Dick Bulteman got some research money, and as coincidence would have it, Dick Bulteman is actually on the board of Informatics Europe as we speak. But then, in the early 90s, he gave me a job. And then that started a research career where we worked together for a while on hypertext and multimedia information. Next slide, please. So here you are. This is my PhD thesis, the cover of my PhD thesis. Basically, I was interested in hypertext from my time in Edinburgh with the company. This is all in some sense coincidence. It wasn't like I was out to go, oh, let's do research in hypertext. It just came across my path, and I saw some interest in there, and I just went with the flow. And then joining the group headed by Dick Bulteman, where actually Guido van Rossum was working. He's the inventor of Python. It was also invented at CWI. They were creating tools to support authoring and playing digital multimedia, which is also cute to imagine now that, you know, here's my phone, multimedia, videos, everything. At that time, it was cool if you had an image on your computer, and we could do that. So anyway, my contract at CWI was temporary. Another great part of being a researcher in academia, you get a temporary PhD position, a temporary postdoc position, and, you know, if there's something amazing happens, you get a tenure track position if you're lucky, but that's something we have to deal with as a field. So I had my temporary position, and I was told if I wanted a permanent position at the institute, I had to get a PhD. So, as I recommend to PhD students, particularly female PhD students, don't have a child before you finish your PhD. And the reason I give this advice is because, yeah, I had my first child before I finished my PhD. But luckily, there's never a good time to start a family. It doesn't matter where you are in your career, male, female, it always takes extra time. So either you decide never to have kids, or you have them when you feel like it. Have them now, have them later, it doesn't matter. It's going to be a pain anyway, but it's great looking after kids. So it's something worth giving up. I wouldn't say your academic career is. It's worth having a pause in your academic career to look after young kids. So the good thing is now, because there are people such as myself and other people who've had kids in academia and realizing it was actually pretty tough, there are far better facilities and awareness for young families in academia. Certainly in the Netherlands, I don't know across all of Europe, but there's prolonged parental leave, there's father's leave, there are ways of looking at CVs, so you take the length of time into account, so you sort of chop off 18 months for every child that a female has had, and for the father, then the number of hours they've actually devoted to childcare. So there is awareness that if you want to propagate the academic population, you have to make sure you can have children in the academic population. So my son, he was born in April 96. I defended my PhD thesis in March 1998. Looking after a young child and writing a PhD. I was also participating in the W3C working group on synchronized multimedia integration language called SMILE. W3C is the body that does things like HTML and CSS, so they organize all these international standards. And while working the working group was fascinating and took a lot of time, it actually meant that my research was actually going out and being used in the real world, which was really great. It meant people were looking at my work, contributing to my work, and helping me think about my work and taking the information out there. But again, it takes more time. And I think what we as a field are becoming more aware of these days, also Gerardine was mentioning H indices. We're trying to think of different ways to reward people's work. So that a W3C standard would be a way to reward your work, which would be equivalent to, say, another publication. And this has to be awareness of your peers and your heads of departments and your promotion committees, but this awareness is developing in the community. So again, if you have problems, let me know and I will talk to people for you. This kind of gets complicated. Yeah, we set up a small company. Which slide am I at now? Slide 8. Do you know which slide we're at now? Yes, here we go, thank you. So we had the SMILE standard recommendation. This was close to the real world, so we thought maybe we should set up a company to allow us to actually sell some of this technology. So Dick Bolteman, he left CWI with 2 colleagues. They set up a company called Informatics. I had worked for at least 2 startups in my career. I knew how hard you had to work. I had, at that point, I think 1 child still, hard to tell. And I thought, no, I'm going to stay in academia. It's much more relaxing. So I stayed at CWI. Oh, that's right. The research group then became headless because Dick Bolteman, he was heading the research group. Then I was left behind with a couple of colleagues who were like doing their PhDs and a postdoc. And the Institute was happy to have a group of 3 people, but also realized that this group had to have a professor in it. So being good at logic, you know, there's a group, 3 people, no professor. There are 2 options. One of us becomes a professor, or we find someone from outside to come in and become a professor. And this is most definitely one of the times in my career when I thought, I'm going to become that professor. I'm not going to have someone come in from outside that knows nothing about hypertext and multimedia and come and tell me who I can give my PhDs to. So I was offered a position in the University of Eindhoven in the middle of the Netherlands. And then discussing with other colleagues, like Eindhoven's miles away from Amsterdam. Okay, it's an hour by train, but if you live in Amsterdam, it's miles away. And I realized this would only be worth my while if they would make me full professor. Not the whole week, like part-time full professor. And this was my attitude. So I sort of went in the interview, and they said, you know, will you come here to be an associate professor? I'm going, no, I need to be a professor. And they went, you need to be a professor? I go, yeah, I need to be a professor. And it worked. And it's not like, I think it was because I didn't care in some sense, because if they didn't make me professor, I wouldn't have to travel, which was great. And if they did make me professor, I could travel and I could have a head of the group in CWI. So it was like a win-win situation, so it was good. And I'd much rather have done that than had an interview. I really, really, really wanted the position, because then you're all nervous and you don't know what to do about it. So if there are options, it's always good to think about these options. So next slide, please. So then this pushing thing, I was starting to get the hang of it. And I realized that my Eindhoven professorship would come to an end. There are Dutch laws, temporary positions, permanent positions, whatever. And I realized that I needed to move my professorship to somewhere else. And I wanted to go to the University of Amsterdam, because there were some people I really wanted to work with. And unfortunately, the professor that led the group that I wanted to work with was moving somewhere else. He was actually retiring. And there was a new professor came in, but the new professor wasn't there yet, so I had to wait till the new professor was there, and then the new professor arrived, and I had to get to know this new professor and go out for dinner and persuade him I was amazing. And eventually he realized how amazing I was, and then he gave me this professorship. It took about 3 years. So that was a long push. I mean, most of you will have finished your PhDs and your postdocs in that 3-year period. So it was obviously something I cared about. Meantime, at CWI, there were various changes in the management team. And it was clear that if I looked around my peer group, I was one of the more senior group leaders. And I could see some of the other senior group leaders, and I'm going, I don't want them in the management team. They're lovely people, but I don't want them in the management team. Thank you very much. So I decided I have to go in the management team. And again, it's one of these things, it wasn't like, oh, no, in 5 years from now, I will be in the management team. It was far more, okay, there are options. I don't really want to go in the management team, but I want much less these other people go in the management team. So how to become part of the management team? So I basically talked to people. I talked to the director, you know, who do you want in your management team? Why do you want them there? I talked to my colleagues, perhaps not the ones I didn't want in the management team, but certainly other colleagues that I thought they might want me in the management team. I talked to them. And in parallel, the director talked to me, and he talked to the colleagues that he might want in the management team. He talked to other colleagues to see if they would be okay with me in the management team. And after a lot of talking, and oh, actually, one of the things I did was I made a SWOT. Have you come across a SWOT yet? Yeah, I hope not. It's strengths, weaknesses, opportunities, and threats. If you've already done a SWOT, your career is wasted. No, it's not true. It's management speak, right? But I made a SWOT about my suitability for the position and reflecting on my own strengths and weaknesses. And also my director was impressed that I was a reliable communicator. So I wasn't saying that, oh yes, all these people think I'm wonderful. It was like, yeah, no, that person thinks I'm good at this, and that person thinks I'm not very good at this other thing. And that, I think, was what made him feel that, okay, I could be in the management team. And to be honest, in the Netherlands, there was this initiative called Talent to the Top. And this was to look at increasing the diversity of teams, specifically to get more women to the top. And it was being taken seriously by many people in the country, including my director. So while I was pushing to become in the management team, the director was also being influenced by his environment to have more women in his management team. So that gave me another point. It wasn't that it's like, oh, she's a woman, we'll have her. It was, we need somebody competent. Oh, and she's a woman. That's great. So I think this was something that would not have happened 20 years ago, but did happen 10 years ago. So this is me to date. Can we go to the next slide, please? Looking back at my nearly 40 years, what I have liked to have known then that I know now. So this is your chance, right? You're getting 40 years of experience thrown at you in half an hour. One of the things that took me a long time to realize is that I'm a woman. Isn't that amazing? I mean, I operated as a computer scientist. I spent my youth at university, physics, maths, all these guys around me. I think there was 4 other women doing physics. I was a physicist, then I was a computer scientist, but I didn't realize the world perceives me as a woman. And if I tell people today I'm a computer science professor, it's like, really? And it's just something that I don't realize because I'm from the inside looking out. And it doesn't have to be women if you're from some minority that people don't perceive as being associated with a discipline, you get the same treatment. However, if you're a guy, you need to be aware that this happens. You need to be aware that when you meet a woman in the street, there is a chance that she's a computer science professor. It might not be a very large chance, but at least give her that benefit of the doubt. And we all operate through culturally ingrained stereotypes. And the more we realize what these stereotypes are, the happier we're going to be as a culture. So, some tips. Be aware how people communicate. Some styles may annoy you. I think Geraldine did a very nice analysis at the beginning with these bad management styles, bad leadership styles. But still you can learn something from them. You can be very analytical and decide what is it about that you don't like. Then you know not to do it. And I tend to be a question asker. I ask people questions. Oh, what do you do? Where did you come from? Why did you do that? Why did you decide to do that? And what I hadn't realized for many, many years is that for the other party, it can at some point become annoying. In the beginning, it's nice because they feel very special and they feel, you know, that they're very interesting. But then they realize they go away from the conversation and they don't know anything about me. So tell stuff too. And although you might be sitting there for half an hour thinking, oh, she's told us a lot, generally in conversations, I'm less good at that. So make sure, tell something that other people will remember and that will be useful to them. There you are. Good communication tip. Next slide. And also, when you have interactions and you're going to meet each other today, you can talk to each other and think about, you know, why you're interacting. You know, how could it be useful to you? Is this a person that could help you later in your career, help read a paper, do a research project together? And at the same time, realize that you're the only one looking after your own interests. I mean, don't be arrogant about it, but other people have the same perspective. So mutually, we're doing things from our own perspectives. If you do say something, make sure it's interesting. The number of meetings I've had to sit in where people open their mouths and noise comes out is just so annoying. So if you're going to open your mouth, make sure something interesting comes out. And, you know, learn from the other people around you, how they say it, what they say it, the leaders, how do you like the leadership that's coming across, or how you prefer not to see it done. And one of the other things, sometimes with groups of women, when groups of women get together, they sit and complain. Don't whine, never whine. It's no good for anybody. Think about the positive things you can do and how you can change things. Next. What is it? You whine, all right. Don't whine. Luckily, times they are changing. So like I said, I've been here for 40 years. I am jaded, I am scarred. I'm still optimistic, however. We have the Declaration on Research Assessment, which you can go to that website and find out. And it really is trying to look at how we can assess researchers in much fairer ways, and not just this H-index and journal factors and things like that. I'm part of a team in the Netherlands looking how to implement this in the Netherlands, recognition and awards. And I can't say we have it solved yet because it's very tricky. We're now looking at the narrative CV. So it's more like you give your best 5 publications and you explain what your contribution is to your field in the science. And then you have to read all these, compare these CVs. It's basically impossible. So we have to find some way between counting and narratives that is useful for both people going for grants and people deciding on the grants. There's a very good Informatics Europe report on research evaluation. I think it's worth reading, even at your stage in the career, because then you get an idea about how others think about how we evaluate research and people doing research. And should you be worried about evaluations? Well, 10 years ago, there were far fewer students than there are now, and it was really, really hard to get a tenure position. These days, it's very, very different. There are so many students, we need so many members of faculty to do the teaching that actually it's not that hard at the moment. I would say the next 4 or 5 years, you're definitely going to get a tenure track position if you want it. And that's also the question. Can we make academia sufficiently beautiful place for you to work if you actually want to stay here? I certainly hope we can, and I certainly hope you'll contribute to it in your future. Thank you very much.
Have the Dr. Wolfgang, who is online, right?
Yes, I am online.
Hi, Wolfgang. Sorry for being late, but we had some initial problems, and so everything was delayed. And the audience, we are going to go for lunch half an hour later session. But fortunately, the lunch break was 1 hour and a half, so we still have time for lunch and then to start the other session. So the floor is yours, Wolfgang.
Thank you. Let me just share my screen. Can you all hear me all right?
Yes, yes, we can hear you very well. So first of all, thank you for joining us. And please go.
Okay, great. Can you see my presentation now?
Yes. Yes, we can.
Okay. Thanks, Elisabetta, for inviting me. I'd like to talk about a project that we did in the UK, and particularly in England and Wales, where we developed the COVID-19 app. And you might ask, what has this to do with early career researchers? And the relationship will become clear in a minute. I am professor of distributed computing at UCL, but that is a role I have very part-time currently. My main job is that I lead the Zühlke Group in the UK, and particularly, but I also serve on the executive board of the Zühlke Group as a whole. And I'm actually calling from Munich right now, so I'm on a group offsite. So we were asked, we won the contract in May last year to build the NHS COVID-19 app. And the COVID-19 app is mainly to track and trace contacts that people have if they then turn out later to have been infected. And I'll explain in a moment how the app does that. But there were very similar efforts around Europe to build such digital contact tracing applications for mobile phones. So we worked very closely with our colleagues in Germany at SAP and with people in Ireland, Neoform, who built the Irish app. But what was unique about the NHS COVID-19 app, and which actually in the end also contributed to the success greatly, was that we also had a number of features that we called me features, that weren't actually public health features, but that were rather features to help the public to cope with the impact of the pandemic. So the app had these 6 key features to alert people about the risk level in their particular neighborhood, for them to check into restaurants and bars. So all in England and Wales, you will find these QR codes, and we scan that people have been in these venues, and that information actually never leaves their phone. So unlike in other countries where people have to leave their contact details with restaurants and bars, we keep that in a privacy-preserving way. There is a symptoms checker, which is in fact the reason why this COVID-19 app is a medical device. And we had to get clearance from the regulator, the MHRA, for it. You can order a test and get your results delivered through the app. And if the results come back positive, the app will help you to keep track of your isolation. And it will also then enable the app to tell your contacts that you have tested positive and that they should self-isolate too. So there were a number of key non-functional needs, as is common with these apps. So it's an app by the National Health Service, which means that it has to be inclusive. So we had to have speech support. It had to be trusted by the public, so it had to be anonymous and private. I talked about the CE mark from MHRC already because it's a medical device. Because so many people in England who are at risk from COVID do not necessarily speak English very well, the app had to be available in 12 different languages. And as you know, the pandemic is constantly evolving. In fact, we have today done about 180 releases of the app and the backend infrastructure to adjust its behavior to the evolution of the pandemic. We built the app on top of the Google Apple Exposure Notification API, which is the sort of middleware that Google and Apple agreed on and built and implemented into their mobile phones. And we released the app open source together with all the documentation. I've given a link here to the open source, or to the page where the GitHub repositories are. So what you might ask, what has this got to do with me as an early career researcher? What I'd like to do is to talk a little bit about the research that actually enabled this app. So one of my first PhD students was Lynda Capra, who's actually now a professor at UCL. And she worked on novel paradigms in mobile computing. So at the time, this was 18 years ago, actually she started in 2000, so 20 years ago. Distributed systems were based on the premise that there were these different transparency dimensions that meant that distributed system components should not be aware of network connectivity, of location, of operating system principles, and so on. So there were a number of transparency dimensions, and this was basically the accepted line of thought in distributed computing middleware. The ISO standards demanded transparency to make it easier to build distributed systems, so that components can recover from failures and so on. And actually, Lynda challenged that in her PhD thesis, and she was the first to argue that in mobile computing, you do want context awareness that needs to break these different transparency dimensions from time to time. And she built a first reflective middleware that would enable applications to adopt to context, which she allowed to define in terms of signal strength and location and reachability of other services and so on. And in fact, the Apple Google Exposure Notification API that underpins all the world's successful context tracing app is an example of such a reflective middleware where the app developers can actually influence and set up the reflection mechanisms for the thresholds for contact tracing. And then the API implementation performs signal strength measurements that actually are exactly the opposite of network connectivity and location transparency, because we do want to know how long the Bluetooth network is in reach and how strong the signal is in order to calculate the distance and the exposure between two mobile phones. So I've given a link to one of Lynda's papers here where she describes that. It's in fact still one of her most widely cited papers, and the previous speaker talked about impact and things like that. So citation is certainly a measure of impact, but the next example shows that actually you can also have impact with research without a strong number of citations. So the development of digital contact tracing was really first done by a dear friend of mine, John Crowcroft, with whom I worked at UCL together for quite a while. And he worked with a postdoc, an early career researcher, on a project called FluPhone. So FluPhone was built in 2011, so more than 10 years ago, in order to try out the use of Bluetooth signal strength for contact tracing. The motivation at the time was that there were nasty influenza pandemics going around, and that it would be useful if phones could actually track who you've been in touch with and who you might have been infected, with the flu. So FluPhone actually had all the classic features that now all the COVID contact tracing apps have had, except they didn't do it for COVID, they did it for flu. And there is a paper which actually hasn't been very widely cited, that Eleni and John published in a special conference on humanitarian relief and in wireless technologies about 10 years ago. But it was this paper that basically set the world off to do digital contact tracing. So when we got involved with NHSX, which is the innovation unit of the NHS, this paper was making the rounds, and they said, wouldn't it be nice if we could do this also for digital contact tracing of COVID? Because at the time, the UK test and trace system was really struggling. So I'll now explain how digital contact tracing works and how we got that to work. So let's assume that we have a number of phones that each have a COVID contact tracing app installed, and there are a number of people. These happen to be school friends of my daughter, and each of these phones from time to time generates a unique key, and then transmits that key to other phones. And these other phones record that key and keep a record of which other phones they have been in close contact with. And then a risky contact is, in the UK, a contact for less than 2 meters for more than 15 minutes, or a contact for less than 1 meter for more than 5 minutes. So we had to calibrate the Bluetooth signal measurement to, as you know, the Bluetooth signal strength decreases with distance, and it decreases significantly when there are walls in between. So we had to calibrate that to approximate what 2 meters mean, and we measure the duration that phones are in contact with each other. And then there are some others. So here in this particular example, Bianca and Henry were close together for more than 15 minutes. And that means that Bianca's phone would store the key that Henry has transmitted earlier. So that's so far so good. And we call this model decentralized contact tracing because these keys typically never leave the phone. They stay on the phone until such time when the phone user agrees that their keys should be shared. And this happens when they are tested positive. So we built a symptom checker, and you can go through the symptom checker dialog, and when you receive a positive test, you get an SMS with a test code that says that this positive test is authentic. And if you enter the test code, you'll be asked, you want to also inform all the people that had a risky contact with you. And this then means if India received such a positive test result, her key would be transmitted to the server down here, and then it would be included in a distribution list that gets pushed out regularly to all phones. And Ian and Bianca would then receive it, and then Bianca's phone would switch self-isolation on, and suggest that actually she should self-isolate for 10 days. Now, this model is extremely privacy preserving because these keys get changed all the time. It is not possible to deduce who the users are. In fact, one does not have to authenticate, and one does not have to log into to the phone. It's enough if it's installed. And in fact, the NHS and the government have really no idea of who the people are who receive these self-isolation notices, and they don't have any idea of what the adherence is either. So we then also built a second feature for venue check-in. I'll just quickly explain how that works. The phone has a QR scanner, and we use that QR scanner in the app, and you can effectively, when you go into a cafe or a restaurant, you can check into a venue, and you then get a result. So we have one of those in our offices too, and then you can also see where you've been. So there's a venue history that keeps aggregating on your phone, and then there are 6 daily exposure checks against risky venues. So a risky venue is a venue where manual contact tracers have tested 2 infections on that day, and then the venue ID gets also distributed to the phone 6 times a day. And if there is a match between a venue you've been to and a venue that's on that risky venue list, then you are encouraged to be careful and test yourself repeatedly. You don't have to self-isolate, but it's an encouragement to test. Now, the UK, in fact, England and Wales made it mandatory to have these check-ins at venues. So you either had to leave your contact details behind the bar on a sheet of paper, or you had to use the check-in feature of the app. And it is this contact venue check-in that really drove the adoption rate of the app. So I talk a little bit about the timeline, which is a bit unusual for a class 1 medical device. So we effectively received the requirement to build this up at the end of June. We pivoted to the exposure notification API from Apple and Google. There was a previous app that actually didn't quite work that a company called Pivotal had built. And we then in 6 weeks built a pilot that had these 6 features that I described. And we did a pilot with that MVP on the Isle of Wight and in the London Borough of Newham. And we learned a number of things. So from the Isle of Wight and from Newham, we learned that we needed more languages, for example. And we learned that there was a great uptake of that app. And then we hardened the production in another 6 weeks. We built that multi-language support that was required. We got the CE mark from MHRA, which means that it's a safe medical device to use. We did AA compliance for accessibility so that people who have visual impairments can have the app talk to them. And we received great feedback over social media from disabled people that the app was usable. And we published a data protection impact assessment with the Information Commissioner's Office to basically put the concerns that people had about privacy at rest. We also published the source code of the app at that time, so that it could be subjected to independent scrutiny by privacy researchers. And we've had very complimentary remarks about that. And then since the national launch on the 24th of September, we have made continuous improvements. So there was a new version of the exposure notification API that took into account some feedback we gave to Apple and Google. We had localized tier messaging. The different nations in the UK have different apps from different vendors. So the Scottish and Northern Irish have decided to procure a different app, and there is different apps in Gibraltar and on the Channel Islands. So we had to build interoperability between them. We then had to respond to the now called alpha variant that first emerged in Kent, which was more infectious. So we lowered the thresholds. We added in isolation payments and so on. So there is a continuous stream of changes that we've done since. So I'm running out of time a little bit, so I'll skip these slides where I talk about how we organize the delivery process and talk a little bit about the architecture maybe. So to build the backend infrastructure of the app, we decided to go all in on Amazon Web Services cloud native features. And this was a deliberate decision to basically enable the scaling of the app. And we used a limited number of extremely well understood patterns. So all the inbound traffic is using CloudFront. The outbound content is all signed. We had a content delivery network to cope with the high volume of distributing all these keys. All the functionalities are defined in lambdas to make it very easy to scale. And likewise, we have timer events from these mobiles when they want to read the new key distributions, and that's also done in Amazon Lambda. So the backend infrastructure is entirely stateless, and the storage is done in S3, and as a result, they scale extremely nicely. So maybe for the technically inclined people, we had 28 million downloads of the app. We get at the peak, we got about 700 million user requests a day, and we served up about 12 terabytes of data, just to get an idea for the scale. And the highest load API is for the data analytics that we added in November last year. And that gets about, at a peak, about 300,000 requests a minute, which is quite high. So I'd like to conclude by talking a little bit about the impact that the app has had, and then I'll take some questions. So the app has now been downloaded as of today. This is a slightly old chart. As of today, it's been downloaded more than 28 million times. In March, it was 23 or so. We've had a large number of venue check-ins. They've tailed off here between December and March because the UK was in lockdown, and there is another peak again over the summer when the lockdown finished. You can see the test results, and you can see the ratio between positive and negative test results every week. So at the peak, we had in January, we had about 100,000 positive test results that were linked to the app. In the peak in the summer, people talked about the pingdemic. We had about 650,000 positive test results that were linked linked to the app, and we believe that the pandemic actually stopped the wave in July. We delivered a large number of contact tracing alerts, so about 250,000 in the peak in around Christmas or just after Christmas, which is quite a large number. And again, that was closer to 700,000 in this summer. And the interesting point about impact here is the infections and deaths that we actually prevented. So my colleague Daphne Tsallis, who will actually become a young researcher, she will start doing a PhD at Imperial, will start her PhD with a paper in Nature, which is no mean feat. That paper summarizes the epidemiological impact that the app has had. And they looked at, in that paper, the cases that were averted in the period. So phases 1 and 2 is the period between the national launch on the 24th of September last year and the 31st of October, the 31st of December last year. And they found through the matched neighbor analysis that we have averted about just under 600,000 infections. And the way they did this, and this was actually Daphne's work, is that they looked at the difference in app uptake relative to neighboring local authorities. So what you can see here is basically that there is a strong correlation between app uptake shown here and the difference in total number of cases per 1,000 people in the population. So the blue trend line very clearly shows that the higher the app uptake is in a neighborhood, the lower the total cases per 1,000 people in population are. And we are really only comparing neighboring LTLAs that are postcode districts that have about 6,000 people, where we can assume that the socioeconomic backgrounds and the ethnic distribution is actually similar. Otherwise, it would be obvious that maybe in neighborhoods in Scotland where there's less population density, the app would not have, or that'd be a difference in the infection rates. So, and if you then look at what this means by means of deaths that were averted, with the mortality rate at the time, we believe that in 3 months at the end of last year, we averted between 4,700 or 13,500 deaths. So the mean is 8,700 from that analysis. So I would now like to conclude so that you get to lunch. So the conclusion is that actually this digital contact tracing through a mobile phone app works, and it's saving lives. The real benefit now is that we have an effective instrument to understand the development of the pandemic. And we were able to respond to some of the challenges of the pandemic. The third point is that we can't really replace manual contact tracing because not everybody uses a mobile phone app and not everybody has the app installed. We need to the government still has a responsibility to also reach people that don't have mobile phone apps. And the fourth point actually did turn out to be true. The pandemic did happen when the government released the lockdown restrictions. And again, the app was very instrumental in controlling that. So with that said, I'd now like to see whether there are any questions, if we have time for questions, Elisabetta.
I think we can have one or two questions at least, given that you are not attending in the afternoon. Of course, if you have time, you will be more than welcome. But I guess you have not. While
yeah, I can't. I'm afraid.
Yeah. While our other speakers will be available, and so you can ask questions also offline or this afternoon. So, do you have questions for Wolfgang? And also online. Yeah. So, yeah, for here there are no questions, but actually I do have a question related to the way you assessed the real scalability of the system, because I understood that your time frame was very short, essentially, and so as you said, you relied on AWS features for scalability, but did you really trust AWS, or you had the chance to do some tests before? So how did it work? How could you really assess the ability of your system to tackle such a large amount of requests and traffic, etc.?
Yeah, so as I said, we did the pilot in the Isle of Wight and the London Borough of Newham, and in total, and there was a third group, actually, the NHS volunteers. So in total, there were about 1 million people in the pilot, and that actually gave us confidence that AWS would be able to scale. And then when we did the production hardening after we had completed the feature development, we actually did load tests and simulated the behavior that we would have on the app. And since we have launched, we have then also looked at optimizations we can do to reduce traffic, also to save cost, because traffic volumes and calling lambdas actually costs per instance and costs per megabyte. So we did a number of different things, and we continuously monitor with CloudFront and Amazon's diagnostics tools the behavior of the backend, because we also operate the app. And in the period since the 24th of September, we've not had a second of downtime. So it's been constantly on.
And what was the challenge, the biggest challenge that you had to face in this rush?
The biggest challenge was to get politicians to make decisions in a timely fashion.
Yeah.
And the way we did that was to actually bring the Department of Health policy team into the app team. And we created basically a startup in the Department of Health that was given autonomy. And then the policy people were actually part of the people who built the backlog.
So to create a connection with what has been said before, this is a way to tackle leadership, not trying to involve people and to create groups that are in which multiple competencies and abilities come together. Do you have other questions? No, our audience here is a bit shy. So thank you very much.
Okay, thanks for having me, Elisabetta.
Yeah,
I'll go and get some lunch now too.
Yeah, so have a good lunch, and we are going for lunch as well.
Okay, enjoy. Bye. Thanks for having me. Bye.
Bye.